Hi everyone, in this video we will look into the example of engineering application of derivative. Okay, let's look at this example. The question said that the air is being pumped into spherical balloon so that its volume increases at a rate 100 centimeter cube per second. How fast is the radius of the balloon increasing when the diameter is 50 cm? This problem is actually derivative problem, but then it's not straightforward. You need to understand what's going on, then only you can solve the question. All right, let's look at the question one by one. Let's break it down into simpler components so that we understand it better. All right, air is being pumped into a spherical balloon. So we have, let me try to redraw one spherical balloon like this. It's not really spherical. Let's say this is the balloon. It's been tied down here. And please kindly assume that the circle is same size. I don't know how to draw it. And it says that the volume increases at a rate. So when we are talking about the volume that increases at a rate, meaning that the volume is not constant. It's changing with time. So here, what it means is dV dt is actually 100 centimeter cube per second. That's what it meant. And how fast, they want to ask how fast the radius of the balloon increasing. So actually, they want to know dr over dt, how fast it increasing when the diameter is 50 cm. So this is diameter. Again, assume that the circle is a nice circle, it's spherical, and 50 cm. So meaning that here diameter is from end to end of the circle, and the r here is actually 25 cm, because half of the diameter. All right. So that's the information that we have. We have dV dt, and also we have the value of r here, and they ask for dr dt. How fast the radius change when the diameter is 50 cm. Alright, so we do have dV dt here, 100 centimeter cube, and as I mentioned, the question asks this, dr dt when r is equivalent to 25 cm. So we are dealing with the volume of the spherical. Okay, if you still remember, I hope you can still refresh what you have learned during school. The volume for the spherical, volume of the sphere is 4 over 3 pi r cube. So in order for us to differentiate and come up with the equation here, we need to know what's really happening for this particularly these cases of the spherical of the balloon. So the V here, if you look at the formula of the sphere, the V here is depending on the value of R. And there's no T here, because if it's not changing with time, the volume of the spherical is constant when R equivalent to something. But now the volume is changing with time. So the volume is changing with time. And if you look at this relationship, this is actually the V here is a linear relationship with the R cube. So as long as the V increase, the R cube will also increase. Same goes with as long as the V decrease, the R also will decrease. Vice versa. Meaning that if R cube is decreasing, the volume will also decreasing. Okay? And if the R is increasing, the volume is also increasing. Okay? Now we have this relationship, but there's no T here. If the volume of the sphere is constant, where R is constant, then we can straight away use this formula. But then again, now we have the V that is changing with time. We have dV dt. And now we have this one will change as well, because it's a linear relationship, will change as well when the R is changing. So we have the dV over dr here that always change when, one is R, V that always change when the R is changing, and we can multiply with the radius that changing with the time. So if I do this multiplication, I can cross, let me change the color of the pen. I can cross here and here, I get back dv over dt, correct? Okay, so there's no problem on doing that. Okay, I rewrote once again the formula as above. So I know what is dv dt because it's given in the question, and I can know what is dv dr because the the equation of the volume here is 4 over 3 pi r cube. So I can find dv over dr here. What I will do is 4 pi over 3, 3 bring it here, 3 pi r 3 minus 1. 3 minus 1 will be 2. So I will get 4 pi r squared. So I'll get 4 pi r squared, and then dr dt. That this is the question. We need to find this. This one is unknown. And also, the question already mentioned that the dv dt is 100 centimeter cube per second. And they want to know when the r is 25. 25, and we can find the dr dt here. So, what we can do is we bring it down here. 100 divided by 4 pi times 25 squared. You get dr over dt. So you can simplify it, and you will get the answer as 0.0127 centimeter per second. Okay, that's how you do and solve for this question.